Well, hello guys. This is my very first video of this kind, so I'm kind of nervous and I don't know how this will turn out in the end, but I'll just have to try it. Anyway, my last video of this very engine you see right here kind of blew up. As of recording this video, it has almost 300,000 views and it got me to more than 1,100 subscribers at the moment. So I guess you could say this is a 1,000 subscribers special and 300,000 views special? I don't know. Anyway, in that video I promised you to do a tutorial at some point in time on this engine, especially on the valves which are inside these dark bluish gray bricks right here, which are, I'd say, my own creation, because similar engines have been done before. Especially Lego Technic Embodiment did a couple of videos on engines like this, but he usually used valves that looked, well, he usually used these types of valves. I think you can see it a little bit better, like this. Those are the exact same ones, just different colors. But my valves are smaller because, I don't know if you can see it, these valves would usually sit about in height wise, they would usually sit around right here. That's where they usually sit, and as you can see, the valve sticks out on top, so it does not fit in there. And also, in order for the engine to work, the valve needs to compress, and that's when it extends on the top, so there's even less space. For a comparison, I actually, since my last video, I made a second engine, this one on the left. You can see it looks almost identical, a little bit different, because this one has these bumps on the top, which the other one hasn't. The reason these bumps are there is because this engine actually uses these valves. Let me show you real quick. That's not the one with the other color. I don't know. Doesn't matter. As you can see, if I hold it right in front here a little bit, maybe a little bit closer. As you can see, this time the valve is actually able to fit inside the engine, and there's even enough space for the valve to compress. So this works. But because of this extra space, this engine is a little bit bigger, technically, even though it's only a very small bit bigger. But still, this is smaller. So no engine exists, as I'm aware of, as of right now, that's as small as this one. And even if you want to be really precise, usually these types of engines have inlets on the top, not on the side like this, so I guess you could say technically this is even smaller. It's smaller than the other engines, but this is the smallest. And this is what this video is going to be about. Maybe if you want to, I maybe can do a video on the other engine at some point. And without further ado, let's strap yourselves in. This will be a long one because there's a lot to talk about, so let's not waste any more time and start with the building of the valve. Before we can start building the valve, you will need some tools. The tools you will need are some pliers, preferably with some cutting element right here. Most of them have it, just make sure you have something to cut metal, probably. Then a small file. I like to use a triangle shaped one. Can you see it? It's a triangle shape, it's very small. You usually get them in a set. You will need you will need a knife, like this, to cut some plastic later on. Make sure it's a sharp knife. These cutters work very good. You can break off the knife. I guess you know that already. Then you will need something to drill. You will need drill bits. To be exact, a 2mm drill bit, a 3.5mm drill bit, a 5mm drill bit. You will need those, and then you will need a thread cutter, a M6, a metric M6 thread cutter, like this. and something to drive it. I like to use just a standard handle like this. If you want to use a drill, you can do it, but you'll need to be very careful while cutting the thread. You will see it later on, so I recommend you use something like this. For all those things, I recommend you use a vise of some sorts. I usually use another one, but for this video I will use this one. And also, if you have for your vise some protection vise grips, would be very good. Those are too big for this vise. As I said, I usually use another one, just so you don't scratch up your plastic parts. I like to use a Dremel like this for some cutting applications. If you don't have one, the pliers are just fine, but this makes some stuff a little bit easier, and I will be using this. Also, you will need calipers to measure at some point later on, at one time. Obviously, you will need some super glue. Actually, there's two different kinds of super glue. This one is a gel super glue, as you can see right here. This means this is a little bit thicker and it's easier to work with in this case. But there's also liquid super glues. Those will work just as fine as this one will. It's just a little bit different to apply. It depends what you have at home or what you like to use. I like to use this one, which is why you'll be using this one. Then you will need some sealant tape like this to seal off the threads you will be making later on. And also what you should probably be having is some kind of cleaning solvent. I like to use this, just something to get rid of any dirt on the parts, so that the glue can stick later on. Also, a electric drill, maybe a good thing to use for the drills as well, because you'll have a hard time drilling with your hands. Yeah, so that's the tools. Now, after we've covered the tools you will need, now it's time to cover the parts you will need. Obviously, you will need a tile and a brick in your desired color. I like to use dark bluish gray, but you can use whichever color you want. Also, you will need a cylinder like this one. It's important to mention that Lego actually offers two different kinds of this, one with and one without a slot. Both will work just fine in this engine, but I'll have to say that we will be drilling a hole in here later on as an exhaust, and you cannot see the hole afterwards with this brick because the pin covers it and it's inside this slot. On this brick you will see it pretty obviously because there will be a hole on the outside, which is why I recommend you use the one on the left. But these are a lot more common these days, I found, and so you might only have the one on the right. If you can choose the one on the left, but both will work just fine. What you'll also need is a spring, like this. You can find those in standard ball pens. They're usually on the front right here, but you will need to make sure that it's the right size. You can find that out by checking if it will fit inside the brick. Mine does, and it's got not a lot of space left, so that's perfect. Also, you will need a Lego T-piece, a pneumatic T-piece, like this. We will be cutting this up later on as an inlet, and also you can use this in the exhaust. And then the most important parts are those two, because these are the two, yes, you heard that right, two valves I use for one valve. So we actually cut those up and create one valve out of these two. The easiest way to get those, because it's not that hard, not that easy, is to order a kit like this. And I got this on Amazon. Maybe I can put a link down in the description. You'll have a variety of valves to choose from, and most of them you will not need, but yeah, in my case I needed the ones in this and that box, and there's not a lot of them in there, so you kind of end up buying a lot of these boxes if you screw up a couple of times, but that's it. Now that we've covered the tools and the parts, we can actually start manufacturing the valve. So the very first step is drilling the brick. For this we will choose the 5mm drill bit and an electric drill, and we will be drilling a hole inside the tube on the underside of the brick. Like this. Now there is a hole in there, pretty much the exact same size. Yeah, that's the first step. The second step is actually one of the more difficult ones depending on your skill level, because we will be needing to drill the M6 metric thread on the tube we just drilled. So the difficult part right here is to get the cutter perpendicular to the brick, like perpendicular on this side, like this, and perpendicular like this on that side. Let me just try that real quick to get the thread started. It's kind of difficult to do like this, but I think I got it just right. And let me just show you. Usually you don't open the vise afterwards. As you can see, it's pretty much rectangular on both sides. That's what you want. And then you can cut the thread, but, big but, not all the way through. You want to make sure that on the top of the brick there's a couple of millimeters left where there's no thread, and I'll show you what I mean in just a second. Let me just drill that real quick. And be careful while doing it, because you can easily break the Lego part. Because, yeah, the measurements kind of don't add up exactly, but it's close enough. I think I need to stop. It's been a while since I've made a valve myself, so I'm not 100% sure on every step right here, but most. So now we've drilled the part, and you can see, I don't know, yeah, you can see now there's a thread in there, and if I was successful, I was. The thread does not go all the way to the top. It stops a little bit, like 2 or 3 millimeters from the top, so we have an even surface there and no thread. That's what we want. In the next step, we will be adding the inlet hole. For this, we add the tile to the brick, and then we will be drilling a hole on the side. I usually drill where the gate port is, right here, from the injection molding, so that you later on will not see it because we drilled it away. So for this, we put our piece in the vise again, and then we will be using multiple drills. First off, the 2mm drill bit, the smallest one we need, again in a drill, and then we will be drilling from this side left to right. We will be drilling in the middle, and right now here we will be drilling more or less in the gap, in the small gap you have between the tile and the brick, but a little bit more towards the tile, because the brick has only a very thin roof, and we do not want to make a leak in that roof, because this is actually you could call it like an airway to the valve. So if there's a hole in the top of the brick, it's just gonna be a leak. So I'll try to drill this now, which is not very easy with the camera. Okay, close enough, I guess. And with the 2mm drill bit, you will be wanting to drill all the way through, and usually with more RPMs than I just did. So it looks a little bit like this. I actually put the hole quite a lot on the bottom, a little bit more than I'd like, but that's the way it is. That's how you do this. Then the next part, we will be drilling a bigger hole. Now we will be needing the 3.5mm drill bit. This hole to drill is a little bit more difficult. We will be using the same hole, but this time we will not be drilling all the way through, because by doing this, the T-piece can later on be inserted in the 3.5mm hole, but it will not be falling through because it will not fit through the 2mm hole. So it's a little bit easier to glue. If you drill it all the way through, no problem, it should still work, but just be careful when doing this, and just like I'll have to be right now. Okay, I think this should be close enough. So this is how my piece looks right now. I'll probably not get it any better. So you can see there's a 2mm hole on the inside and a 3.5mm hole on the outside. And the 3.5mm hole does not go all the way through, so the T-piece can sit in there. If we take the tile off, you can actually remove the dirt. You don't want that in there. Like this. This is what it looks like on my piece right now. So you can see the 2mm hole goes all the way through, and the 3.5 is only on the surface as an indentation. That's what we want. And also make sure when you're doing multiple valves, do not mix up the tiles and the bricks, because they will also always be matching to each other. If you use another tile, it will probably be in another spot though, so they will not match up later on. Just make sure to keep them together from now on. So after we're done with the drilling, we will be needing the knife, because now we will improve the airflow to the valve. As you can imagine right now, the valve will be sitting in here later on, in this hole, and the tile has a tube in the center that blocks this hole off. So how is air gonna get to there? That's what we're gonna solve right now. We will be doing some strategic cuts on both parts, on the brick and the valve, on the brick and the tile, sorry, and to improve that. For this we will be using this knife, and be very, very careful. I cannot state enough how careful you will have to be, because you will probably be cutting this straight in your hand. Do not cut yourself, please be careful. These knives are very, very sharp. I've cut myself before. I do not plan on doing it again. It will probably happen at some point, but just be careful. So what we're gonna do to the brick is we will be cutting off the inside quarter of the stud right here. I'll try to do this in front of the camera, just like this. Like this. You can see now there's a cut, so the air can pass by this brick a little bit better, because the tile actually sits on the outside of both sides of the stud, so now the air can pass by on the inside. We will do this to all 4 sides. On the tile you will do something similar, but also different. You have the tube in the middle, and you will be cutting a V shape in there on the same sides where there is a straight edge. But make sure to not cut all the way to the bottom, because the spring later on sits in here, and if you cut all the way to the bottom, the spring could potentially get out of there. But we do not want that, so don't cut the V all the way to the bottom. Oops, I just touched the camera. But cut it a little bit on the top. I'll try to do this in front of the camera again. You see, now there's a V in there. My camera will focus like this. And this allows air to get in there, and we also still to have some plastic on the bottom that can hold the spring in place later on. So I'll just do the other 3 sides on both parts, and then we will do the next step. So I've added the cuts to my parts off camera, so now you can see all 4 sides have the cuts we will need. And now that we've cut the plastic parts, it's time to cut the metal parts, our valves. We will need to destroy both of them before we can make something out of them. That's life, I guess. So I'll use the small pliers I have, and you can see the valve has a little bulge on the top. I'll just get my pliers and cut that right off, like this. Then we can remove the spring, we don't need that anymore. On this one, we can remove the plug. We don't need that anymore, we don't need this anymore. We will be needing this first valve, the small one. On the bigger valve, it's the other way around. So we still cut off the bulge on the top, like that. Remove the spring. And on this one, we actually can throw away the body. We will be needing the plug, because these two actually do fit together quite nicely. And because the original valve uses a rubber on the side to make a sealant, which we do not want because it creates a lot of friction. And on the bottom there's just brass. And with this configuration, there actually is a rubber on the bottom which seals against the valve body, and on the side there's brass, so low friction when opening the valve, but still sealing against the body. That's what we want. Now, the first thing we can do with the brick and our valve body we just cut up is to screw them together. As a test, with those boxes you'll usually get a tool, but you don't really need it in this case, but it can make things a little easier. So you use the brick and the valve body and you insert it on the bottom right here, and then carefully thread it in. Make sure to not cross thread it, because this could ruin your plastic part and you'll need to make another one. But it usually at this point is quite easy to do. And just screw it in all the way, and it should look something like this. You can see it sticks out a little bit on the bottom. That's okay, that's how it's supposed to be. Just make sure that it fits and it works like this. And also, I showed you, we do not want threads all the way to the top. Now you can see why, because the body of the valve actually does not come up all the way. You see, it remains down there a couple of millimeters, and you do want to have a smooth wall above the valve body. That's what you want, a little bit like this. So the next step again is a little tricky, because we will be cutting up our valve plug. And also it might be a little bit loud because of this thing, so headphone users, I guess you've been warned. What we're gonna do, we will be first of all creating some bypass holes, I'll call them, because as of now you can see that there's not a lot of room on the outside of the valve plug. So the air comes from the bottom and has to go past it. Right now it can't really, because the valve plug plugs the entire hole. So we will need to add some slits to the side. You can do this with the file as well. I'll be using this one later on too, but it's easier to do it with a tool like this. And also to hold the plug, I use my bigger pliers because they have some ridges on the inside, which makes it easier to grab like this and then drill into it. Also, when using a drill like this, it also always rotates in one direction. Make sure you do not hit your eye with the debris coming off of there. Or also always wear protection glasses. Yeah, so I'll try to do this, and yeah, let's see how this works out. So that's how the venting hole looks like on the side. Right there. That's one. I want to, I usually add 5 of those in a star-like shape, and by cutting in the side, like you just saw. Also, there's a rubber O-ring on the bottom. Make sure to not cut that or hurt that, because this will create a leak, obviously. And yeah, I'll just add the other 5 and then come back. So this is how my part looks like now. As you can see, it's got a beautiful star shape in there. It usually always looks a little bit, yeah, strange, because it's made by hand, so your spacings will not be perfect. And what I also did, I used my file I mentioned before, and I did widen those cutouts a little so that even more air can pass through there, like this. That's what I did. So now the next step is to shorten this spring. In my case, I will need, I know I need exactly 2.5 windings. It might be a different amount of windings depending on your spring, so you will have to find that out yourself, I guess. Also, you can see on the end the spring is woven a little bit more tightly. So on this spring the effect is not that intense, but on some springs the windings actually they are not as far apart on the end. So you will need to pay attention to this, because if you just pay attention to the amount of windings you have and they get shorter in the end, you will actually end up with a shorter spring. So let me just cut up my spring real quick. So I have another older one which I already used, and what I do to count the windings is I usually go and insert it right here in the plier, and then I can see where it would be cut. I don't know if you can see it. It's on the left side here of the spring, and then I just turn it 2.5 times inward. So that's 2, and then another half. Then I know I have the right length. Also, I recommend you to cut it a little bit longer than you would need to, like this, because you can always shorten it. It's very hard to cut your spring a little longer, but it's easy to cut it a little shorter, like this. Very tiny thing. It's really, really tiny. That's what you end up with. What you're gonna do now with tiny pliers you have, you're gonna take one end of the spring and bend it inwards to the middle. Yeah, so it should look a little like this. So on one end the spring is bent towards the middle. Why do we want this? Because the spring will sit above the valve plug. So we have the brick right here, and the plug is inserted like this, and then the spring sits on top, like this, with the bent part on the bottom, directly on the plug. Because we've bent it, now the spring cannot get stuck between the brick and the plug. It will always sit on top of the plug, so the valve does not get jammed up. That's why we need a bend like this on one side, on the downward facing side. On the upper side you don't need it, but you do need it on the bottom. It's very important. Also, the length of the spring, you can adjust this right now. For this you'll need the tile, the brick, the valve plug, valve body that's screwed in on the bottom, and the spring. So you can right now add the spring, as I said before, with the bent part on the bottom. You cannot see it. And then you will add the tile on top. While adding the tile on the top, make sure that the spring gets inside the inner tube of the tile. It can get out of there sometimes. You can see it probably, I don't know. So it's in there, and then you can close it up. Then it's good. And you will know, as you can see now, valve has a spring in it. That's what it's supposed to be like. And you know you have the right length if the valve is barely getting pushed to the bottom, but it has to be firm on the bottom. It has to be in there. If it's loose on the bottom, then the spring is too short. If you feel like your valve is a little bit too hard on a spring, you can shorten the spring a little, but be careful. Do very small cuts because right here a small cut can make a really big change. But yeah, that's what your valve should look like right now. The next step is to cut the length of this. Obviously right now this is way too long and we need it a little bit shorter. So I will be using a Dremel for this, and to measure the length, my calipers. We will be needing exactly 2 millimeters. So that's this. As you can see, it's aligned with the 2 here. That's how long this should protrude out of the body right here, out of there. The easiest way I found to measure it is just setting the caliper to this length and then just comparing the length to this. If it's still longer than the caliper is set, then it's too long and you'll know you will be needing to shorten it. I will be cutting it with the Dremel, as I said. You can also cut it with a plier like this and then sand it down. You could just cut it, that's it, like this, and then use sanding paper to sand it down. But when doing this, make sure to not press too hard, because obviously this is sprung. So you'll have to do this very carefully. It will work, I have done this before. It's just a little bit easier with the Dremel. So yeah, let me just cut that up real quick. So like this. I've intentionally made it a little bit too long because after cutting you usually have a rough edge like this, and we don't want that, we want a straight edge. So you can see it's a little too long, probably like 3 millimeters or so. And what I will do now is to change the blade, because this is a cutting blade and not a grinding blade. So now that I've changed out my blade, as you can see, this is a little bit thicker than the previous one. This is the previous one. This is made for grinding. It's a little bit worse at cutting, which is why I use the other one, but it's better at grinding. Now I will use my part and press this against here very slightly, because this takes a lot of material off very fast. And then I'll repeatedly check the length until I've got the right one. Check again. Now, as you can see, this is almost perfect. So that's what you want. Now it's 2 millimeters exactly. And that's the length we like. Also, because of the Dremel, now we have a straight edge that looks very nice and that we can use. So now we will be making our nozzle. For this, we use the T-piece we've seen before. And before we can cut it up, we will be needing to drill it, because right now it has very tiny holes, which air has a hard time getting through, obviously. So we will use our 2 millimeter drill bit from before and our pliers to hold it. I find this the easiest way to do this. And then we drill. You've probably seen this to Nick Jasno before. And it's a little bit tricky, but you'll figure it out. Like this on one side, and the same thing And the other, as you can see now, there's a much bigger hole than here. That's a difference. So that makes the airflow a lot better. And that's the other side. Get off there. Yeah, that's the drilling part done. Oops. Now we can use a knife, and we just need to cut up or cut away one of those three sides. Which one doesn't matter really, and if you do multiple bars, you can use all of them. So I find the easiest way to do this is on a table. You can just not see a lot of when I do this, but I like to go all the way around before cutting all the way through, because if you do not go all the way around, you can end up with a crooked cut, and you can waste a little bit of length of this plastic part, and it's not a very long part, so you will be wanting to use up almost everything. And after I went around it, I can very carefully cut through it without cutting myself. Like this. Now you've ruined a Lego part. Oh no. But now we have this part. So the next step is gluing these parts together. The tile to the brick and then a nozzle. And now you can also see what I meant before. Because of the bigger hole, we can get the nozzle in there, but it cannot fall through. Like I said, it's not the end of the world if you drilled with the big hole all the way through, as long as you don't have created a hole right here, but it makes gluing a little bit harder. But before we can glue, we first need to clean all surfaces. Gluing relies on clean surfaces, so by having a clean surface, we ensure that our gluing will hold up. This super glue usually is very strong and it's pretty nasty stuff, so it gets the gluing done even if the surface is a little dirty, but we do not want to take any chances, am I right? So make sure to clean up all our parts before we glue anything together. So now we can take the parts again and make sure to not touch the surfaces where we want to glue. We take our super glue, open it up, and then first off we glue the brick and the tile together. So for this we apply some super glue around the edge, all the way around, but not in the hole, not where we drilled, but basically everywhere else. So more or less like this. And that's why I also said that it's easier to work with a gel-like super glue, because it stays up like this. A fluid or a liquid one would flow more towards the side. So now we can use the tile, if you don't drop it, and put it on there, and be like this. And you can see there's a little bit of extra glue. Now we just take the wipe we just had and wipe it along the edge we glued, like this. And now by this we get rid of any additional glue left over, and our part looks like this, glued together. Now, before the glue hardens, if there should be anything in the hole, we take the nozzle before, and now we apply the glue around the end. Should look a little bit like this, and then you can take that nozzle and just insert it into the brick, which can be a little bit tricky, and it's in. And then once you've done that, just make sure that it's perpendicular. It's not that important, the angle, but I just like if it's straight. And then a very important part, do nothing. Let it dry, especially the nozzle. Usually the super glue dries up very fast, but because we applied quite a bit of it right here, it can actually take a little bit of time. So leave it be, put it like this, straight up so it won't fall over, and just let it sit until it's dry. Now, while our valve is drying right here, we just leave it to the side. We can actually work on the cylinder. I told you before we are drilling a hole inside here. For this, we take our good old 2mm drill bit again, and our drill, and we drill in there. It's very straightforward. For this, we just insert the drill in the slot, as you can see, and you want to aim like this, almost in the middle, but slightly a little bit to the top. You could also look at the upper edge of this right here. That's where you want to drill. And also, while drilling, make sure to not hit the other side, because you could scratch it. So insert your drill far enough to the inside so you do not hit the other side. And then, oops, you can just drill like this. And that's it. Usually one hole is enough. As you see, now I have made one hole right here. On the inside there's one hole as well. You can add another hole on the other side. I have done this with my other engine, but I don't see any benefit. Also, you need to make sure that there's no residue left from the drilling, so use a soft edge like this nail, for example. Use anything with a soft edge and just make sure to get any residue out of there, so that there's a smooth wall, so it will not hurt our ceilings later on. So now that we've glued our brick, we can insert the valve parts again, but before we do this, we first need to seal up this thread, otherwise it will not be airtight. For this, we will be using our Teflon tape, fat sealant tape. I cut up a small piece right here, and then we just take this tape and roll the valve body inside it. But you will need to make sure that you roll it the right way around, because otherwise the tape will unravel itself when you insert the part. For this, just take the part like this, lay it on top of there, and then roll it to the right. I usually do 3 layers. That normally is enough, and it looks like this. Wrapped up in it, and then I just take a knife and carefully remove it where it's not needed. So that's how it should look. Just some tape around where the thread is, and on the top and on the bottom it's free, so the air can get through there. Now you can take this body, your valve, and the other parts you made, the plug and the spring, and put them back together. For the spring, make sure to put it with the bent part towards the piston, so like this, and just drop it in. And you can see how it's in there. Like this, that's what it's supposed to be like. Okay. Then, after that, I find it the easiest to just take those two and put them together like this, and hold them like this, and then just insert it and then carefully thread it in. Carefully, because you've now created some extra stress for the thread because of the sealant, and to make sure to not cross thread it. Now you've threaded this in and it should look like this approximately. I do have to say, because I'm filming in front of the camera and it's really hard to work right here, this is not airtight. First of all, I do have a crack right here, which is not optimal. If you find this on your part, you should probably redo the brick, and ideally you find this before you thread it in and glue all the parts to it, so you only have to redo the brick. That's one part, and also I think I have damaged the rubber o-ring I told you about before on the plug. I think I've damaged that, so this is not airtight. And usually when I have the valve like this, it's very easy to test for how good it does hold up. So I take my air hose connected to the valve, make sure the nozzle is dried up all the way when doing this, unless you want to redo the gluing. And ideally, if you put pressure on there, you will not hear anything. In my case, this leaks pretty bad, as you hear it. So this is really, really bad. This is not usable at all. But that's how the valve works. Just to show you. I have a valve I sorted out before. This one. This one's not perfect too. It leaks a little bit of air, but it's much better than the one I just showed you. So that's this valve with pressure, and you can hear it leaks a little bit of air, but not much. But still, I thought that was too much, and I replaced it with the ones in the engine right now. But you can hear this is a lot better. My compressor is actually running out of air right now. So under pressure it should not leak at all, and once you open it, it should leak air. That's its job. After you've made sure that your valve is airtight, unlike mine, you are ready to glue again. So that means cleaning first. And this time we will be cleaning the cylinder a little bit of the frame. We will be cleaning the cylinder and the valve as well on the other side. And then, just like we did with the brick and the tile before, we'll be gluing those two together. For this we use our super glue again, and we apply the glue around the outside of the cylinder. And it should look a little bit like this. I mean, you've seen this before. Always when you do this, make sure right here that you have a closed loop, so that there's glue everywhere, so that there's not that you don't have a leak later on. Now you can glue on the brick in any orientation you want. I always glued them with the nozzle facing outward, if this is outward, like this. And then the exhaust hole, you can see it's on this side, on the other way that the nozzle is. So nozzle and exhaust hole opposing to each other. And then, just like with the brick before, on there, press it in, and it should look like this, with a little bit of residue left. And once again, the residue, you can just wipe it off with a paper towel real quick, and that's it. You've created your own valve. In my case, a very leaky one. In your case, hopefully a airtight one, like the ones I use in my engine. But still, the process is the same. This one's better. You've now created your own valve. So that's it for the valve, and the next part will be how we get from this to this. So now that we've made the valve right here, hopefully yours is not leaking as mine is, it's time to make the engine. Before I assemble the engine, I just want to talk about the parts you'll need for that. Obviously the valve itself, we just made that, and then a couple of standard Lego parts like the piston, the connecting rod, obviously the engine block holder, some axles, a 4 studs long axle and an 8 stud long axle with an end stop. That is what I use. A grill piece, this plate and this slope part, that 3 long beam, and yeah, some pins. That's basically it, I think. Also what's kind of Lego, I guess, is the hose right here. You can use standard Lego hoses. I don't, because, well, they're pretty expensive and I think in transparent they look better. So I bought a roll of hose a long time ago. It used to be 25 meters. So this is just any ordinary plastic hose. It's got an outer diameter of 4 millimeters by 2 millimeters on the inside. So I'll just show you real quick. So it's 4 millimeters on the outside. If the camera will focus, yeah, and 2 millimeters on the inside. Or you could also, that's easier. All thickness 1 millimeter. So 4 minus 1 times 2 is 2 millimeters on the inside. You can buy that on the internet, on any site you find. Also, you'll need screws, very tiny screws. Mine look like this, 2 millimeters by 12. I cut off the last millimeter or so because they are very pointy there, so I don't need the pointy bit, and also they're a little too long. What you also can buy is the bearing right here. You'll need 3 of those for 1 V8. They look like this, or I have a couple of them. They are 10 millimeters on the outside, 6 millimeters on the inside, and they are 2.5 millimeters wide. Also, what you can buy are some nails. I use them for stiffening up the engine. You can use any piece of round metal, or you can even use some tools. I just found they work very good. They are 3.2 millimeters in diameter, so they work perfect. And I later cut off the end, and you'll see that in a minute. What you also can buy is these are rubber O-rings. That's where I got them. They are 4 by 1 millimeter, and I recommend you get a couple of them because they can break, or you can wear them out where they are not properly sealing anymore. You'll see that in a minute. So you'll have a couple of replacements ready. There are some parts you'll need to make yourself. That one right here is optional. I combine this with this to make the intake look a little better. You can see that right here. That's where the part is. You don't need to use this. I do because I think it looks better. What you also need to print, obviously, is this, the crankcase on the bottom. This adds support for the crankshaft right here. This is where the bearings go, and it holds the engine together a little bit more. Also, what you'll need to print is those parts. Those are my own crankshaft design. I talked about my hybrid crankshaft. This is the hybrid part because it uses partly metal. That's how I did it. It used to be a round piece of steel that I milled a rectangle on the front and the back. The rectangles do align to each other, and that's how I make my crankshaft. I'll put up the files for my own parts in the description. This is not made by me, it's made by VEEEERY Lego channel on YouTube. I'll put up the link for his part too. Yeah, and for my parts, depending on the crankshaft layout you want to use, either cross plane or flat plane, you'll need different amounts of parts, and I'll probably make a list on Thingiverse or so, like depending on which layout you want to make, how many parts of each you need to print of each version. Yeah. So that's a part you'll need. Now let's assemble the engine. Now, making the engine or assembling it. I'll cover this really quick. First of all, obviously you make 8 valves, 4 on V8. Then you put them together with standard Lego pins like you would a normal Lego engine, and you should add some lubrication, but I'll show you how that's done in a minute. Then you add your crankshaft of choice right here. Usually you do this without breaking the crankshaft, but no problem. Just put it in and put it back together. Come on. Right there. That's one side, and the same for the other side. You probably do not have a tubing on there, but that doesn't matter. You can add the tubing at any point. Actually, it's more difficult to assemble the engine with the tubing on. So once you've done, once you've inserted the crankshaft, you can add the the engine block holders. You do have to do some twisting like this, so that the tubing is not in the way anymore. I actually just broke it. Put it back together. Right here, just like this. And in front it's the same. Like this. Come on. That's that. Okay, I like to add this bushing and the gear to turn it a little easier. Then you can add your crankcase like this, and add the screws so it will not fall off once you run the engine and the engine pushes actually against this. Make sure to not overdo the screws. Very gentle. This. Push in the bearings a little bit. You can do the intake whichever way you would like. I do it like this. I think it looks good. And then the only thing that remains to do is adding in the metal bars you have, or the metal rods, let's say. In the last part, I said you need a nail. This is actually a nail. It used to be a nail. Where do I have it? Right here. As you can see, this is the same. I just did saw the head off, so that I have a rod. And like I said, I used a nail because it had the perfect diameter, 3.2 millimeters. It's just where I can put the rod in, and it will not fall out. So that's the assembly of the engine. A quick note on the crankshaft, how that works. That's the parts. You need these, they hold the bearings. There's a cylinder right here. Then you take a bearing, just put it on like this, and then you have this piece. You'll notice on the one side that's where a square is. That's where the metal part goes, and on right here, on the cross, on one side, it's shorter. The side where it's shorter, that's where the square is going. Let me just put it on. Here, you can see it fits perfectly like this, and that's where you insert the metal part, and then your connecting rods can run on there. That's just one segment, obviously. On the back right here is the same, and that's why you need to pay attention to what parts you're printing, because the side where one of the cross members is shorter obviously needs to match the crankshaft layout. that's that. Also, one thing you can do, I didn't show you the tubing. Well, it doesn't really matter how you connect the tubing to the engine. Each cylinder makes its own stuff. It just needs air, so any way you get air in there is fine. I did it like this because I thought it looked good and it's very compact. So if you want to do it like mine, I guess you can just copy what I did. Obviously you have to drill these T-pieces like we did before, and I did it on the other side as well, just mirrored basically. That's how I did this. Also, bending the tubes, I did heat them, so I can show you what I mean by this real quick. For that, I take a candlelight, and a glass of water. Maybe the other way around, it's easier for me to do. Then you take a little bit of tube, like this, and you heat it up over the flame in one area, so where you want the bend. I like to rotate it while I do this so it gets heated evenly, and then you can see you can bend it really easily. Once you have bent it, you can just insert it in cold water until it gets cold again, and then once you get the water out, the tube stays like you bent it. That's a neat way to do, or that's how I did the intake or the tubing on the engine. Yeah, that's it basically. Also, there's for the crankshaft there's a front and an end piece where my axles with an end stop are inserted, and you will need to cut off a little bit of plastic right here, but I guess that you can figure that out yourself. Another thing I want to talk with you about is engine maintenance. Most of you have probably seen my engine. That's probably why you're watching this video. So then you also know that it's not supposed to sound like this on low RPM. You can clearly hear one cylinder misfiring. I don't know which one it is, but I suspect that there's a broken seal inside which creates this sound on low RPMs. I mean, on higher RPMs it's more or less fine, but still I will need to do some replacements on here. And I'll take you along the way, and while I'm at it, I will talk to you about how to lubricate this engine. So first off, if you've made this engine, I suppose you have if you're watching this, the first thing you need to do is remove the screws from the bottom. And now we can lift off the crankcase and screws fall out. There, put them aside. That's the engine. You can see there's actually a flat plane in there, which is why it could rev so low actually. The crosspin is not able to do this. Also, what you can see right here is a lot of dirt. I cannot find my pen. There it is. You can see there's lots of black debris. This is not supposed to be here. You can see it's gooey stuff. It's loose. This actually is rubber. It's rubber from the rubber O-rings I showed you before, because they rub against the cylinder walls, and if there's not enough lubrication they wear down, and the debris or the dust, I don't know what you would want to call it, ends up down here and it gets caught in the oil. So yeah, it's not supposed to look like this. If there's some black stuff on there, I mean, it's not the end of the world. A little bit of yeah, wear and tear is normal, but that's probably a sign that you ran the engine too long without proper lubrication. So let's take the engine apart and swap out the O-rings. For this, we first remove the top, in my case, which is just a decorative part, and then we will be needing to push out the nails. This is perfect, like this. Come on, yeah. There it is. Then just use the pliers, pull them out like that, all four. So now you can disassemble the engine. That's the front. The back is a little bit more tricky because there's tubing and stuff, but normally it's no problem. You can pull it out and then twist this away like this, and you have two halves, two inline 4 cylinders, I guess. And now you can just pull them out like this. There you have the crankshaft. The crankshaft with the cylinders, and you can see there's also black stuff on the cylinders. This one has quite a bit, so I guess this one's faulty. I don't really know. I'll just replace all of them just because I want to make sure to get it right. Yeah. So I guess I'll replace them off camera and I'll be back. So I have replaced all the O-rings on my crankshaft with new ones off camera, and I've wiped down the crankshaft a little bit to remove most of the dirt. And yeah, now before we are reassembling the engine, we will be doing some lubrication. It's necessary. You will need to lubricate your engine, and the lubricant of choice in my case is this. It's silicone spray. It's just German right here. You can ignore the glide word. Silicone spray. Why this and why not that? Everyone's favorite, WD-40. Well, there's a reason for this, because WD-40 is a lubricant that's based on mineral oils, and the problem with mineral oils is that they are aggressive against rubber materials, which we are using right here in the seals, or for example in the tubing. So we do not want to use WD-40 because it's a mineral oil. The solution to get around this is a synthetic lubricant like silicone spray. That's why we use this. So yeah, you can use any silicone spray basically. That's just one from my local hardware shop. So for lubrication, we take our engine block. I have it with the tubes on it, basically doesn't matter. And I like to hold it like this and then just go to town with lubrication. Oh, that's maybe a little bit much. Outside the engine it's not doing anything. And you see it pops out right here. And then you have lots of lubricant in there. Also what I like to do is, you can probably not see it, with the hose to go in there and push the valve down a little. And while it's pushed down, also pump a little bit in, because that way the lubricant gets behind the engine as well, behind the valve as well. So there's lots of oil in there. It doesn't matter if there's too much, it will get out on its own. Also, lubricate this thing, the crankshaft. Basically, you cannot use too much, and I actually like to use some wipe. Oh, don't fall apart. Oh, come on, get back together like this. And just lubricant primarily on the pistons right now, because you cannot really get to them later on. And once they're all nice and lubricated, you can start to insert them back into your engine. And that's, well, basically just putting them in. Very straightforward. Nothing to explain right here. First one side, ideally without breaking the crankshaft. problem. And it's in. And then the other side the same. Come on. In there. And that's it. So we have it like this. Then we can add our crank, our engine block holders. I don't know what the pieces are called. We can add those back in. Just like we disassembled it, I like to twist this one in place. It's a little bit tricky, but you'll figure it out. Like this, one side and the other. And the front is very easy, just put it on there. And that's it. It's back together now. Those on there, so it's easy to turn. Like this. And now once it's assembled, you can also give it a little bit of oil on the connecting rods, on the bearings, basically anything that's moving. Give it a little twist. And that's it. So now put everything back together basically. Crankcase on there, screws in place. And the screwdriver to screw it back in carefully. It's very tiny screws in plastic, so it's easy to over tighten them. Like that. And what I also like to do when I still have the top off, you saw the bearings. Now you can use something thin. I have my knife right here, and you can push down on the bearings so they are properly seated. They'll seat themselves because of the pressure, but still, like this, you can help it out a little bit. And then insert your metal rods again into the engine. Don't touch the camera. Throw it out of the way. And just them in there. And then the top back on. And that's it. It's assembled again. Now we can also give it a test. Let's see. And you see it runs. I think it runs smoother. A little. Yeah. That's it. You've made your own valves. You've made your own engine. You've maintained your engine, and you can have fun with it. And yeah. I hope you enjoyed the video. Like I said, this was the first time for me doing something like this, and I guess this will be a very long video. I don't know yet. I'm still in the middle of filming, but if you've made it all the way to the end, I thank you very much. This was a lot of stuff to take in, and I hope I answered all your questions. If there's anything left that I have to answer, just ask me in the comments. I'll do my best to answer all of them. Sometimes it can take a couple of days, but usually I'll get back to you. And yeah, that's it. Thank you for watching. I hope you liked it, and I don't know when it will be, but see you in the next one. Thank you. Bye bye.